Well, welcome to our next section. Our next section are basically about the new topic, right? Last time we have seen was the limit definition of derivative, which is approach the secant line, or in other words, the difference of quotient, into the collection of slope of tangent lines. And the collection, we call that derivative. Right, in this section here, we will use the rules to find out the derivative. Now, section 2 is about the basic rule. Basic differentiation rules, and rates of change, right? They are related, but the majority part is about the basic differentiation rule, right? So two things are the formula we use. The first one is derivative of any arbitrary constant equals to 0. That's the first rule. Derivative of any constant respect to, in our case, the variable x. Since the constant is just a number, graphically we can see it's a horizontal line, right? So we get a 0. And the second is derivative of any x to the power n. For n to be positive, to be negative, to be rational expression, or it could be a fraction, like 1/3, 2/3. Even x to the 0 is a constant here, right? But we'll have x to the n. Derivative, what we do with the x to the n is take n as a coefficient. Before it was a power, so it becomes coefficient of the term x to the n minus 1. Right, so take power down and the expression will have one power less. So that was the formula we use. I try to keep that, remember them, or at least have them somewhere recorded. To prove it, we use the definition, d dx of c, a constant, that is a limit of h approaches to 0. The difference of quotient, but since we do not have any variable x inside, when we substitute x plus h, that is still a constant. Constant minus constant over h. We get the numerator to be 0, the denominator is just approximate value. As we see from the last section, this is not exactly 0, right? That is h. So when we simplify it, exact value divided by an approach value, that we get here is still 0. Which we take the limit h approach to anything of just the value 0, that will give us 0. So that's how we prove a derivative with respect to x of any constant equals to 0. Right, we need to prove of that. We're doing same thing, right? F of x plus h minus f of x over h. In our case, f of x plus h, that is the nth power of x plus h, which you need the thing called binomial expansion. After that, we're looking for factors of h squared, then factors of h, right? Terms containing factor of h squared and terms containing factor of h for the difference. Right, as for f of x minus f of x plus h minus f of x, the difference. We're having factors of h squared and factor of h. After simplifying, we can divide to see which term or which terms will be left over to take limit of the expression, right? And to see which term will remains afterwards. That is should be at the end after everything taking limit, all the terms should be cancelled out, should containing the h, then we have only the term n times x to the n minus 1 as power left over. So this one, I leave it for you to try. Try it. Right. For the binomial expansion of two terms, right, that we have a plus h raised to the power n, you could able to find it online, right? That is not only the expression, but try to understand what that means. Maybe required a little bit knowledge from counting principle in probability or basic statistics, right? Maybe you need them. But still, I think if you read the explanation, you would understand at least about the expansion, what that means. And when you consider those of the things, then maybe you figure out how to do them. Right? It's not hard, right? So try them. But the conclusion is that the constant will be 0 and the derivative of x to the n power, we take n down as coefficient times x to the power less than 1. Right? You will see where it's coming from. And then a short conclusion is, or a short thing we have, right? We usually use the x, right? The x we just have its derivative to be 1. Well, once we have the power is to the first power, the coefficient is 1, but x to the 0 power is also 1. Right, so when we derivative the x respect to x, that we have a 1 there. Right, algebraically or graphically, we have the slope of a line which is y equal x. The slope is 1, simply. Right, so that's some result we use. Right, just keep them in mind. Constant x to the n, and then we go to x, right, to get that. This n, again, could be anything. Right? It could be any number. Fractions, decimals, even the whole number. Everything could be applied to here. So find the derivative. Right, so that's what I mentioned the last section. When we say find the derivative, use definition, that is the only case we use definition. If we just think cleanly or clearly, that's just find the derivative, which it usually refers to use the formulas. Like the two formulas we have seen, it will be some more. We'll see at least 2 more in this section, and then a couple more next section about trigonometry. But something we'll see later is trigonometry, but here we'll have is simply called the power rule, right? The power. So f of x given equals x to the third. F of x could be cube root of x. F of x could be a fraction, or simply fraction. I find the derivative of each one. This one, well, it's cleanly that we have x to the third power. So what we can do is the derivative f prime of x is just we have power, copy it, x to the 3 minus 1, which is 3x squared. Right, it's clean enough that we just take it off and power minus 1. Right, this second is cube root of x, which is not the format that x to the certain power, but that is radical, right? So we could a little transform to make it a radical, that is x to the 1/3 power. Right, since the radical is exponent as rational exponent. Right, therefore f prime of x, coefficient is 1/3, and the 1/3 minus 1. Well, 1 over 3 minus 1, that is negative 2/3. Which I hope, or I think, or at least I hope, you understand that the negative exponent will not be kept as the final answer, or we should be making it positive. How to make power positive is it goes to the denominator. Right, then when we see, well, it's 2/3, and we could make them together. Cube root of x squared. Right, that's x to the 2/3, which is cube root of x squared, right? Or cube root of x squared, same thing. And the 3 on the denominator should stay there. That is the derivative of x to the 1/3. Right. Similarly, y equals 1 over x squared could be transformed, become x to the negative 2. Right. So the derivative y prime will be negative 2 carry down times x to the negative 2 minus 1. Well, no problem, that's negative 2 times x to the negative 3. And this negative 3 will be flipped down again into a fraction. And 1 over x to the third. Then we get, well, that is negative 2 over x to the third. Right? Of course, leaving as this expression is not acceptable, we have to change the x to the positive exponent, or not only that, but maybe into radicals, right? You keep as exponent is okay, but keep as radical will be more clear of what this expression is, right? Like when we evaluate the expression for some x value, usually radical will be a better way to evaluate it. And here negative power usually is not acceptable, right, for the final answers. So that is the power rule. You could try yourself to see what you get, right? Do more examples and you will master it. Another property is for a function with coefficient in front of it, the derivative of that is just constants times f prime of x. Right, so far we had, that is our third rule, right? The first rule is constant derivative equals 0. The x to the n has power rule, that n power taking down as coefficient become n times x to the n minus 1. And here for any arbitrary function f of x, it always holds that the coefficient of function when we take derivative becomes the coefficient of the derivative of the function. This one, prove it. By definition, that is still a composite function, right? It's not composite inside, but it is a scalar multiply outside of the function. So which when we take the derivative, that is limit definition of the function with variable x plus h, which our function is cf of x, so cf of x plus h minus cf of x over h. That is the coefficient when we can factor it out. C times the limit h approach to 0, f of x plus h minus f of x over h. For where the derivative of f of x exists, that is the c times f prime of x. Right, so the scalar multiply doesn't affect the result. Right? Also means the scalar multiply holds for the property of derivative. Right? Derivative, when you have a scalar inside, it could be taken out. Then it is the scalar times the derivative. So try to find the derivative. right? Of course, the function have the variable x is acceptable, other variable like t or any other letter is also acceptable. Right? Not necessary the function is a variable of x. It could be variable of t, the same thing. We take the derivative of function respect to t, it's same thing as we do it with respect to x. Right? So for this one, y prime will be constant. Right? The coefficient is coefficient. When we take derivative, that's still coefficient. Times 3x to the 3 minus 1. Which we can do the operation here, right? Before we have single constant, single coefficient. Now we have the coefficient and the power become a new coefficient. Then when they multiply together, that's 15. X to the second. Right, so that is the y prime equal, if you want to write it, 15 x to the second. This question here, the t is on the bottom, so we need to fix it a little bit. F of t equal 2 times 1 over t, or 2 times t to the negative 1. Right, that's first. Then when we take the derivative respect to t, which is the coefficient here is 2, the power of t originally of the original function was negative 1, so carry down. And we have new power negative 1 and minus 1. Negative 2, t to the negative 2. That is negative 2 over t squared. Right, so just treat the other variable same as the x, right? If we put f of x to be 2 over x, then we'll have negative 2 over x squared. Similarly, we have f of t equal that function, then we have f prime of t is negative 2 over t squared. Right, that's is the involving coefficient. We try something more. Right, we have fractions. I have fractional coefficient and some other things we see. Alright, so the one way you could do, right, f of x, simplify it to become 4 over 5 times x squared. Then f prime of x coefficient times 2 x to the 2 minus 1. That 4 over 5 times 2 is 8 over 5 times x, which is 8x over 5. Right, which simply we see as the coefficient with stays as where it is. Right, that will be a very official or nice way to do that. Right? Or if we have x to the positive power on top, what we can do is just f prime of x will be 4 times 2x to the 2 minus 1 over 5. That is 8x over 5. Similarly, right? Similar two things, which give yields the same result. If for the beginner, right, you can do this way to do a long way, right? And when you're getting familiar to it already, we see x have a positive power stay on the numerator, then it could be done a little faster. And this one definitely we need simplify or transform. That's 1/2 times 2/3, or we'll do step by step. Right? 1/2 times x to the 2/3. That is 1/2 times x to the -2/3. Right, to get the coefficient times x to a certain power. Then we could apply the power rule. 1/2 the coefficient remains. The power, we carry that down. X to the -2/3 minus another 1. For -2/3 minus 1, you can use calculator to check. That will be -5/3. And when we multiply 1/2 times -2/3, that's -1/3. And if you want to write step by step, that's -1/3 times 1/x to the 5/3. And the cube root of x to the 5th. Or if you want to write step by step, that is what it will remains. Of course, if you want to multiply them to leave it as a power, it is acceptable. Only not acceptable is the answer being remain as negative exponent. It is acceptable when it make an exponent. Also, it will be acceptable when it remain as radicals. That is the power rule, simply. Which the coefficient usually remains as coefficient is kind of, people usually do, right? Familiar with that way. Coefficient is still coefficient. And then the next rule is the combination. Right, the linear combination of f of x plus or minus g of x. That is just the derivative separately. The derivative of the combination could be taking its derivative separately. That's what the formula say. Right, so of course more than 2 terms, more than that will also apply. F of x and g of x not referring to singleton as we had seen, it could be multi-terms. Then for multi-terms, we could do combination separately to take derivative of each term. That is the formula. Well, it is simple enough. Right, before we had seen was the single terms, now we see something for more terms. Right. For the first one, it's simple enough that the derivative y prime will be 3 times x to the 3 minus 1 minus 4 times 1 plus 0. Right, since we said before the derivative of x is 1, if you remember, and derivative of constant is 0. Only, which is all of them are power rules, and the power rule here is carry down and power minus 1. that the y prime is 3x squared minus 4. And given f of x equals negative x to the 4th over 2 plus 4 of x squared. Right, for this thing, we could simplify f of x a little bit. Right, that's negative 1/2 times x to the 4 plus 4 times x to the negative 2. Right, just separates the coefficient with the term of x. Not necessary for this x to the 4th, since that's 4x to the 3rd, and then still divide by 2, it's the same thing. But for the second term, we have to simplify it, since that is negative 2. We showed that, right? We have seen one thing before. So we just remain it as the same x to the 4 over 2. Then f prime of x will be apparent. That is negative 4 times x to the 4 minus 1 plus 4 times negative 2 times x to the negative 2 minus 1. And negative 4 over 2, that's negative 2 x to the 3rd. Positive 4 times negative 2, that's negative 8. X to the power negative 2 minus 1 is negative 3. And the first term is nice enough. The second term is, well, have x to the negative 3 power. That's we have seen before. It's just carry that down. Negative 2x to the 3rd minus 8 over x cubed. That is the expression. I show step by step very carefully, and if you're getting now, I mean later on, right, maybe next section I could be skip some steps, like not showing this thing, right? X to the 4, that will be 4x to the 3rd. X to the negative 2 derivative will be negative 2, x to the negative 3. I just not show it, you don't have to show it on the paper if you're comfortable with it. Right? Of course, if you want to show steps, totally fine, right? Totally good. What we didn't touch was this type of function that is a rational function, right? We didn't touch it yet. Of course there is one way to do, but we hadn't touched it yet. But when we observe carefully, right, the denominator is a singleton. What it means is we can divide the denominator into each of the terms on top. Right, that we can simplify it or transform it into the division. Right, that's what we had seen in algebra. Right, the denominator will be a divisor of each term of the numerator. That's what it means by a division. Right, so when we divide it, we get 3x squared minus 1 plus x to the negative 1. All the terms become power. Then we find derivative. F prime of x will be simple enough. 3 times 2x to the 2 minus 1 minus 0. The first coefficient is 3. X to the second will become 2 times x to the 2 minus 1. Right? And the minus 1 is a constant. Plus negative 1 times x to the negative 1 minus 1. Well, here f prime of x equals 6x minus 6x minus 0 cancel plus negative 1 is negative 1 times x to the negative 2, or simply 6x minus x to the negative 2. That is 6x minus 1 over x squared. Right, so referring back to the power rule we use, constant becomes 0 and still the power rule we use. Right, that we have a single term on the denominator which can be divided into the each term of the numerator. Right, so even though we didn't touch the quotient or rational expression yet, how we find the derivative of rational expression, we didn't touch yet, but that is what we can do. Right, simplify it. Make it into the terms we can deal with. Three things we can recall. In the limit section, we have seen is the limit of x approaches to 0, sine of x over x equals 1. 1 minus cosine of x over x equals to 0. Right, that thing is what we can recall. So, and another thing was the limit x approaches to 0 of 1 plus x to the 1 over x is equal e. Right, based on these three things, what we have formula is d dx of sine x is cosine. Derivative of sine is cosine, and also the derivative of cosine equals negative sine of x. Two formula, maybe I'll write on the other side. The derivative of sine x equals cosine x. I always put this parenthesis to show that this x is the variable of the trigonometric function. I hope you can have that habit as well, even though it will be a little bit comfortable to write without the parentheses, sometimes using theta to refer the angle, but with parentheses, it will be a little bit benefit when we put things into calculator or when we use the programming language to program it. Right, so the third one we'll see it a little later, but prove this one first. Prove the sine. Right, so derivative of sine right, the difference of quotient x plus h f of x over h sine of x plus h minus sine x over h. right? The expansion of sum of angle of sine, that is sine of the first angle cosine of h plus cosine of the first angle times sine of the second angle of h. Of which we have 1, 2, 3 terms, sine of x, and the sine x are able to be combined together. Cosine of h minus 1 plus cosine of x sine of h. Well, which we have the two sums, right? Could be separated into two limits. Just separate it first. Sine of x h plus the limit of h. Right, two limits. The limits are the expression of h, so the function has variable only x can be taken out. Right, that equals sine x times limit plus cosine x and from the object we had seen before, right? The sine x over x as x approaches to 0 equals 1. 1 minus cosine x over x, same as the referring, right? As x approaches to 0 as equal goes to 0. So the first limit approaches to 0, second limit approaches to 1, which 0 times sine x is 0, cosine x times 1 is cosine of x. I use the definition to prove that derivative of sine x equals cosine x. Right, and this similar way to find the derivative of cosine x, you can try it. I leave for you to try to do it.